The real difference between circuit design and software programming is much more than just the syntactic difference between, for example, VHDL and C. Circuit design is about the physical world of real electronics. That means that when you design the circuit, you do continual trade-offs and judgments regarding what can and cannot physically be done. This is a classical engineering work, just like bridge building. However, software programming resides in the abstract world of pure logic. Software programming is only about expression of abstract operations. So just like circuit design was like classical engineering work, software programming is much more like mathematics done by mathematicians. It is a pure abstract reasoning process that has no practical questions to it. At least not of the physical kind, such as bridge building or electronic design. The problem is that electronic design is much harder and takes much longer time than software programming. To achieve software programming, you need to have a device that physically embodies a model of execution. This model of execution creates the abstract world of software. This is the essence of what a computer processor does. It is a device built in the physical world of electronics that embodies a model of execution that allows the abstract world of programming to come into existence. The Mitrion platform has as a goal to do precisely this for FPGAs. The Mitrion platform consists of the Mitrion Virtual Processor, which is a configurable processor, or rather a configurable processor design for a fine-grained, massively parallel soft-core processor. The Mitrion processor is about 10 to 30 times faster than traditional CPUs at around 20 to 25 watts. And this device is what actually executes a program in an FPGA. Apart from the Mitrion Virtual Processor, Mitrionics has also developed the Mitrion C programming language. Mitrion C is an intrinsically parallel C family language that we use to write programs for the Mitrion Virtual Processor. And finally, we have the software development kit containing compiler, debugger, processor configurator, and all the other aids and tools that you need for programming in Mitrion C. The Mitrion Virtual Processor is fine-grained parallel. By this, I mean that it is parallel at the level of individual instructions. It is also a configurable processor design. It is configurable in two different major ways. The first way is in what processing elements that are used inside the processor. So for example, an application that does a lot of multiplication but has no division at all in it will not even have a divider. So the processor will not be capable of doing division, but the space that would otherwise have been used for the processing element for doing division will now be given up to multiplication instead. And since division is an expensive operation taking a lot of silicon space, you will be able to fit in multiple multipliers in the same space, increasing performance for the program quite a lot. Another important adaptation of the processing elements is that each processing element will have the right number of the right bit width size for the specific operation that it's going to perform. The main point of the Mitrion Virtual Processor is that it allows software programming of FPGAs. You program the Mitrion Virtual Processor rather than design hardware to put into the FPGA. The way the MVP works is basically that it is a set of pre-designed and hardware-verified hardware tiles created by our electronic engineers. There are roughly 60 different kinds of tiles, and each kind of tile will be able to do a different kind of operation. So some of the operations that the tiles do are, for example, arithmetic logic or I/O, and other kinds of tiles are control flow tiles, which are very important. We'll talk about that quite soon. The tiles can be connected to each other in any way, and they are guaranteed to function correctly regardless of how they are connected to each other. This means that any operation can interact with any other operation. Because we have a full set of control flow tiles carefully selected, the whole tile set becomes Turing complete. This means that there will always be a configuration of tiles for any program that you can write, and this is provably true. So there is a guarantee that no program can ever be written for which there is no configuration of tiles that would perform that program. Each tile also has adaptable register and bus widths between 1 and 64 bits. So each tile is capable of, each tile exists in, you could say, 64 different versions, depending on the bus width you want into each tile. So the Mitrion Virtual Processor is essentially the tile set and the way these tiles interact with each other. Each one of the tiles of the Mitrion Virtual Processor is capable of operating simultaneously with any other tile. This gives the MVP massive parallelism, and it's from this parallelism that the high performance of the Mitrion Virtual Processor arises. It also has very high silicon utilization, and it is capable of giving this performance at around 25 watts. The most efficiency is gained from the Mitrion processor when accelerating data-oriented programs rather than control flow-oriented programs. In contrast to hardware design, the Mitrion processor offers portability and scalability. Because you write your program for the processor, you're not designing a circuit for a specific FPGA platform. That means that when a new FPGA comes out, in a new generation, you just configure a processor for the new platform from your old source code. This means that there will be easy upgrades for the next generation of performance, and also, very importantly, it will enable you to exchange code with colleagues on other FPGA platforms. All they need is a Mitrion processor for their FPGA, and they will be able to execute your program. So this illustrates how the Mitrion platform interacts. On the far left, you have your source code written in Mitrion C. That is compiled, and then the compiled code, the resulting machine code, is put into the configurator. The configurator also has access to the processor architecture and will configure the processor into the right configuration for the program that you wrote. Once the Mitrion processor has been correctly configured, that is, the right tiles for that program have been selected in the right numbers and so on, and they have been interconnected in the right ways, then this configured processor can be put into the FPGA and executed.